welcome everybody. So we are going to continue on with our 6.2 notes today. We're going to start with number 4 here. I know we are skipping some. Everything that we do skip, I'm going to make a third video on, but since we have the minimum day today, I wanted to get through kind of the tougher questions and the word problems from this section. And so I kind of had that plan going for today. And then I'll make a third video. I actually think that the third video will be optional. I don't think it's super crucial. I think we'll get through all the most important stuff right here in class today, okay? All right, so let's take a look at number 4 here. So for this one, you can see that they're asking for this x side down here. And so thinking back to what we did yesterday, we did some SOHCAHTOA to find missing sides. And so so thinking back to what we did yesterday, let's see. We need a right triangle to find missing sides. And so is this big triangle a right triangle? Well, I see here, this one's 36, this one's 50. So that adds up to 86, which means this one's 94, right? So this is actually not a right triangle, the big triangle. But I noticed that if I break this apart into some pieces here, I do have a right triangle. Whoa, sorry about that. I do have a right triangle right here. And then I have another right triangle right here. And so if I kind of look at those two right triangles, I have a lot of info on them. I'm going to call this side A, and then I'm going to call this side B. And so if I can find those two, which it looks like I can, then I know that x is just A plus B. So this is going to happen sometimes in these more challenging ones where we can break apart the triangle into kind of different triangles and find those pieces, and sometimes we'll add them together to get kind of a big piece here, okay? Okay, so let's find A and B here. So I'll start off with B just because it's on the left. So from B, we have 36 here. And so this is the opposite side. And we know this is the hypotenuse, which means B is the adjacent. And so I know the opposite side is 85. I want to know the adjacent side, so that's sounding like a tan to me. So we're going to do tangent of 36 equals 85 over B. Like we saw yesterday, when we have the variable in the denominator, we multiply that over to the other side. And then we divide the tangent over back to the right side. So it's going to be 85 divided by tan 36. All right, from there, we got to type it in the calculator. 85 divided by tan 36. I want to make sure I'm in degree mode here, so I'll check that. I see I am in degree mode because we're dealing with degrees here on this problem, and so it is 117. Well, close enough to 117 that we'll call it 117, okay? All right, so now finding A is going to be very similar here. We see we have 50 degrees, and if we go across there, we have our opposite side is again 85, and our adjacent side is again the one we want to know. So I'm going to use another tangent here. So I'm going to say tan 50 now equals 85 over A this time. So once again, then we have our variable in the denominator. So this is going to end up as A equals 85 divided by tan 50. And that'll be 71.3. So then to finish up this problem, now that we have A and B, we will just add them together here. And that I got 188.3. Yep. Great. So a little bit more challenging than what we did yesterday, but not really. We just had to kind of piece two of them together, right? Okay, so let's take a look at number 5 here. So on this one, we're looking for side x down here. Now, that is part of this kind of obtuse triangle right here. So that's not a right triangle, so I don't love that. So I want to find some right triangles here. Well, I do see one right triangle right here. It's kind of a small right triangle, but I have a lot of info on it. And then I actually see another right triangle, which is a big right triangle right here. Okay. So what I'm going to do is I'm going to call this big side A down here, or that that side on the bottom triangle, on the big triangle. And I'm going to call this side on the green triangle, I'm going to call that, I'll call it Y. So then I can kind of see here, I think I'm going to be able to find A and Y. And so what's the relationship with A, Y, and X? Well, it looks like X plus Y equals A, correct? It's two small pieces adding up to the bigger piece. But what's more important for me here is if I subtract that Y over to the other side is X equals A minus Y. So if I can find A and Y, I can subtract them and get X. So I'm just going to use SOHCAHTOA here to find A and Y, all right? So let's go ahead and find, let's find A first. Why not? I guess if I was going to say why not, I should find Y first, huh? Why not? Haha, get it? All right, let's find Y first then. Why not? Okay, so for finding Y, then we're going to do 56, and then this will be our opposite side. Y is our adjacent side. So I'm going to use tan again. So tan 56 equals 115 over Y. Again, we have our variable in the denominator here, so it's going to be Y equals 115 over tan 56. My calculator is telling me that's 77.6. Okay, so now I'm going to try to find A. So on the big blue triangle, I have 35 here, and 115 is still my opposite. And A is going to be my adjacent. So what do you know? I'm going to use tan again. You know, it's getting to be summertime here, and we know that because sun's out, it's getting warmer, and we're seeing a lot of tans. Ha 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 ha. Get it? Tan. Okay. All right, so once again, variable in the denominator means that it's going to be 115 over tan 35.
So what's the kind of variable beyond the denominator?
So Max just asked in here, is most of the time the variable in the denominator? No, usually it's like, I feel like in my life it's about 50-50. But I feel like in this section of notes that we've done, it's been like 80%, right, of the variable in the denominator. So I don't know. I feel like it's close to even actually. So it's just a statistical improbability that happened on this section of notes. All right, so you get 164.2. All right, so now that we have our two variables, A and Y, I can subtract them. and we get 86.6. I would say a lot of times on the same problem, if you have to do like two different trig functions, it's probably most of the time it's either going to both be on, it's going to be on variable on bottom on both of them or variable on top on both of them. It's going to match up like that usually. Okay, so those are kind of the challenging non-word problems we're going to be doing in this section. So try your best to kind of break it into pieces. Find right triangles. That's really the key there, okay? Because the right triangles we can use SOHCAHTOA. All right, now we're going to switch over to word problems. All right, so this is a very important diagram because most of the word problems we're going to be doing in this section are either angle of elevation or angle of depression. So this diagram does a really good job of displaying that. What are angle of elevation and angle of depression? So the thing I always point out is that both of these angles are created with a horizontal line and a diagonal line, whether that diagonal line is up or down. Okay, so angle of elevation is horizontal, diagonal up. The angle of depression is horizontal, diagonal down, okay? So you can never create an angle of elevation or depression with a vertical line, all right? Okay, so a giant redwood tree casts a shadow that's 532 feet long, okay? So I'll draw a giant redwood tree, and by that I mean a rectangle, because I can't draw. So cast a shadow that is 532 feet long. Now I know shadows kind of travel through the air, but at the point that you could measure a shadow, the shadow is on the ground, okay? So whenever they give you a shadow length, that's always on the ground. So I'm going to go ahead and connect these to make a right triangle here. And so the sun is obviously up here, right? And it's creating the shadow. And it says the angle of elevation of the sun is 25.7 degrees. So do I put that up here or do I put it down there? Well, if you remember, I said that we never create angle of elevation with a vertical line. So I'm not putting it up here, only with horizontal and diagonal line. So the 25.7 degrees goes right there. I want to know the height of the tree. So it looks like I want to know the opposite side, but I do know the adjacent side. So this is going to be another tan. So we have tan of 25.7 equals x over 532. Here we go, Max. We got the variable on the denominator in this one. So we just multiply it over. So x equals 532 tan 25.7. All right, so I got close enough to 256 there that I'm just going to call it 256 feet. Tall redwood tree. Are redwood trees the tallest trees, I think, right? Why do you think they call them redwood trees? Oh, it's because the wood is red. It's a little bit red, yeah. Why do they call it Walgreens, though? I went into Walgreens, the walls were white. It's a deal. All right, let's move on. All right, so we've been using a lot of tangent today, and actually I will say for angle of elevation and depression, probably about 80% of the problems with those angle of elevation and depression are actually tangent, but that means 20% are not. So let's take a look at number 7 here. This is actually not tangent here. All right. So we have a building here. And then we draw the ladder. So they say the ladder is 15 foot. And we know the angle of elevation is 32 degrees. and they want to know how high the ladder goes up the building. So you can see here, we want to know about opposite, and we know the hypotenuse in this case. So since we're dealing with opposite and hypotenuse, we are going to use sine here. So sine 32 equals x over 15. So now we're on a 2-problem streak here of the number in the denominator, variable in the numerator. So we'll go ahead and multiply that over. 15 sine 32. $7.9, we'll call it. So there we go. All right, number 8 is going to take a long time to do, and I don't think we're going to have a question this difficult on our quiz or test. So this will be one of the ones I do in the video. If you'd like to do it, if you'd like to see how this is done, go ahead and watch that video. Part 3 video, that'll be optional. But if not, I think it's okay if you skip it, okay? Up to you. I do want to do number 9 though, because this one we are going to have on a quiz. I already know because I really like this question actually. So it says a water tower is located 325 feet from a building. So I'm going to draw the building right here. I'm going to draw the water tower right here. And we know that they are 325 feet apart. So there's an observer, it says, in the building in a window. And he has an angle of elevation to the top of the tower and an angle of depression to the bottom of the tower, which means he is somewhere in the middle. I don't think it's the exact middle. So it's just somewhere in the middle, okay? And so I'm going to draw a line right here, and then he has an angle of elevation to the top, and then he has an angle of depression down to the bottom. So the angle of elevation, remember, is from the horizontal up. So that is right here. From the horizontal up. Now, a lot of people, when they draw angle of depression, a lot of people draw it right here. That is not correct, okay? See how this angle is created with a vertical line and a diagonal line? That's not the angle of depression. Angle of depression is always with a horizontal line and a diagonal line, so it's actually right here, okay? Now, this 325 down here is the same as this line right here, right? So now I have 2 right triangles here. I know an angle on each of them and a side length. So I can definitely do some SOHCAHTOA. I'm gonna have to kind of do this as 2 separate triangles. So I'm gonna see this one as A. I'm gonna see this one as B. And then I know that the height of this water tower is going to be just A plus B. All right, so let's find A and B now. Right off the bat, it looks like both of them are tangents to me. So we have our angle here. This is opposite. This is the hypotenuse. So 325 is the adjacent. So yes, I'm going to use tangent of 39 equals A over 325. So that means that A equals 325 times tan 39. So 253.9.
Oh, it's 39.
Oh, thank you. 263.2 then. Yes, that sounds better. All right. Now we're going to do the same thing down here. So now we have 25 degrees. This is our opposite. 325 is still our adjacent, you can see, because the hypotenuse is over here. Okay, so I'll use tangent again because I don't really care about the hypotenuse. So, but now it's tangent of 25 equals b over 325. So kind of the same setup as our previous one, except now we got 25 degrees instead of 39. So that'll be an easy change in the Desmos. You get 151.5. All right, so now we can do our height here. A plus B, 263.2 plus 151.5. That'll give you 414.7 feet. Beautiful. Yeah, I love that problem because it's like angle of elevation and angle of depression together in the same problem, putting together two triangles to make a bigger side length. Awesome. Okay, so we're done there with notes. All right, so like I said, I'm gonna make a video that'll cover everything that was not covered in this section. This next whole page here, I would really only say this is really kind of for the SAT. It's actually not in our textbook. I added this page for SAT prep. Now, you seniors are done with SAT prep, and I understand that. So I would definitely say like emphasis on the optional for you seniors. But for you juniors, I would really encourage you to do this page on the video because there are questions like this on the SAT, and knowing this little page could really help you out with that. Okay. But I'll also do all the other questions like number 8 we skipped, and then some ones earlier we skipped. I'll do that on the same video. So kind of like I said, that third video will be optional if you'd like. Okay. What would I like you to work on this weekend? Well,